So continuing with the ideas on straight lines, coordinate geometry at large, let me add a few more things to the set of things. And what I'm going to teach next is not just about straight lines, it's about coordinate geometry in general. So there are times we talk of a moving point. We talk of a moving point P. This moving point moves along this trajectory. This moving point is moving along this trajectory, say. This is the path of the moving point. This is the path of the moving point. And it would obviously do so subject to a set of conditions, geometrical or otherwise, geometrical or algebraic conditions, right? This path traced by a moving point essentially is referred to as the locus of the moving point. The path traced by this moving point is essentially referred to as the locus of the moving point. Now, while this point describes a certain trajectory, let's say we are talking of the xy plane to begin with, then at various instants of time it will have coordinates x comma y. X and y would be different for different points on this trajectory. X and y in general would be different for different points on this trajectory. An algebraic relationship that would connect the x and y coordinates of this moving point. There is an algebraic relationship that would connect the x and y coordinates of this moving point is called the equation of the locus. So we have this locus, which is essentially the trajectory, right? And then we have what's called the equation of the locus. Equation of the locus, which is what? Which is a relationship that would connect the x and y coordinates of this moving point. That means for all xy's that lie on this trajectory, that relationship connecting the x and y coordinates must hold good, right? Say, if I have a point A and a point B, two fixed points. A and B are, say, two fixed points. All right? And P be a moving point. Say P be a moving point. And somebody tells you that P moves in a manner. With locus, there would always be a condition. With the locus of a moving point that you're trying to describe, there would always be a condition in some form or the other, right? It could either be a purely algebraic condition or it could be a geometric condition, right? One way or the other, if let's say somebody tells you that this point moves in a manner, that the area of triangle PAB is constant. Say AB is 5 units and area of triangle PAB is, say, 10 square units. Somebody tells you that P moves in a manner that area of triangle PAB is 10 square units. Now, one thing for sure, no matter where P lies, the altitude from P onto AB, suppose that's H. The altitude from P onto AB, suppose that's H. Then can I say no matter what, half of 5 into H. For all positions of P, half of base into altitude, that must be equal to 10 square units. Yes or no? That means P must move in a manner that H must be 4 units. H must be 4 units. Yes or no? Right? That means P moves in a manner that its distance from AB remains 5 units or 4 units. Distance from AB remains 4 units. Yes or no? Now, how can the distance of P from AB remain constant? If P moves in a manner such that it always lies on a line parallel to AB, it always lies on a line parallel to AB, right? So, if A and B, let's say, were lying on the x-axis, suppose A and B were lying on the x-axis, right? Then, if I had to, suppose this was the x-axis and A and B were lying on the x-axis, right? Then, this would be, one of the possibilities is, this is like y equal to 4, yes or no? Isn't it? This line would be y equal to 4 because h is 4 units. This line would be y equal to 4. No, there is another possibility. P could have been on this side and then y would have been minus 4. Y would have been minus 4. So the locus of P in which case would have been either y equal to 4 or y equal to minus 4 would describe algebraically the locus of the moving point P, which always is commensurate with this condition. Yes or no? Right? That's the locus of this moving point. Clear? Suppose if there is a point C with coordinates 3, 5 and a point P moves in the xy plane, a point P moves in the xy plane such that its distance from C is always 4 units. Distance from C is always 4 units. Obviously, we know that the path described by P must be a circle with center at C and radius equal to 4. Right? Now, while P describes its trajectory, what is customary is, this is what we do. Say, at any given instant, suppose h comma k, this is the procedure that we follow. So, suppose h comma k be some specific point on the trajectory of P. That means on the locus of P. Then, the distance formula, h minus 3 whole square plus k minus 5 whole square must be 4 squared. Now that is not just true for this P, it's true for all P's. That means I can go ahead and generalize this. If there is any other point x comma y on this trajectory, then you can replace h by x and k by y and the same condition will hold good. Yes or no? So you generalize this. This is true for one specific point, but it's going to be true for all xy's lying on the trajectory proposed. That means the equation of the locus of P is obtained by generalizing this. Replace h by x and k by y. So x minus 3 whole square plus y minus 5 whole square equal to 16 would be the equation of the locus of P, which is actually a circle centered at 3, 5 and of radius 4 units. Clear? Now, can I wipe this off? There are times that there would be some parameters involved in the description of the locus. Let me tell you what to do in case there are parameters. Suppose we have a ladder AB of length a plus b units. We have a ladder AB of length a plus b units. And the point A could slide on the floor, the point B could slide on the wall, right? That means, in as far as the length of the ladder is concerned, that's going to remain a plus b. That's going to remain a plus b. Yes or no? The length of the ladder will not change. We'll assume it's a rigid ladder. It's not, its length will remain constant, right? Now, while the ladder slides, the orientation of the ladder is changing with time. The orientation of the ladder is changing with time, yes or no? That means, essentially, if you think about it, this angle theta is changing with time. This angle theta is changing with time. Yes or no? Now, if this angle theta is changing with time, then theta is like a parameter for this situation. Theta is a parameter for this situation, right? So, theta is my parameter here. Clear? Now, I select a certain point on the ladder. I mark a certain point on the ladder P. I mark a certain point on the ladder, say P. And I mark it in a manner that it divides AB in the ratio. That means P divides AB in the ratio AP is to PB is A is to B. Suppose P divides AB in the ratio A is to B. Suppose P divides AB in the ratio A is to B. Now, while the ladder slides, the point P moves to various locations. There is a point that I have etched on the ladder. There is a point P that I have etched on the ladder such that this length is to this length is A is to B. This length is to this length is A is to B. So obviously, you know, very clearly the total length of the ladder is A plus B. And if this is to this is A is to B, that means this length has to be A at all times. This length has to be B at all times. Yes or no? Because the total length of the ladder is A plus B. Clear? Now, while the ladder slides, see, this is one position of the ladder with a certain theta, and the point P is here. While the ladder moves to this position, let's say the point P comes to this position, and so on and so forth. Yes or no? Right? So while the ladder keeps sliding, that means theta, the parameter keeps changing. Theta is changing. What changes while the ladder slides? The parameter theta changes, right? The point P, which divides AB in the ratio A is to B, keeps moving to newer and newer positions. There is then, if you join all various positions of P's, there is going to be a path associated with P. There is going to be a path associated with P. There is a trajectory, yes, which will depend on theta. There is a trajectory associated with P. There is a locus associated with P, right? We want to find the equation of the locus or the path traced by P, right? Now, what you do is the procedure, because you're just beginners, so let me just take you through things in a very simplified manner. Suppose at a certain instant, the value of the parameter is theta. And at that instant of time, let's say, this point P that we are talking of has coordinates h comma k, k say. Now, the value of h and k will depend on theta. The value of h and k will depend on theta. Now, let's see what that's going to be. Now, if this is theta, so is this. This is theta. Yes or no? Now, look at this. Would you want to believe that this is b cos theta? This length is b cos theta, and that this length is a sin theta? This length is a sin theta, yes or no? If this is a, this is going to be a sin theta. If this is b, this is going to be b cos theta. Yes or no? Right? Now, very clearly, b cos theta is the x coordinate of P, and a sin theta is the y coordinate of P, the moving point P. Right? The actual coordinates of the moving point will depend on the parameter. For different values of the parameter that it can subscribe to, you'll have different values of h and k. So then I have like h equal to b cos theta at a given instant when the parameter has a value theta, and k equal to a sin theta. Yes or no? Now, my objective is to have a relationship between the x and y coordinates of the moving point. Please listen to me very carefully. These are very simple things, and should be registered right now, right here. My intention is, once I have modeled the x and y coordinates of the moving point in some manner, keeping the condition of the problem intact, right? I seek to now connect the x coordinate h of the moving point with its y coordinate k, which will be the same for all thetas. I want a relationship between the x and y coordinates of the moving point, which will be true for all positions of p. And if it's true for all positions of p, that means it should not depend on theta. If I'm seeking a relationship connecting the x and y coordinates of the moving point, which is universally true for all positions of the moving point, right? This moving point has various positions, very many positions depending on theta. Now if I'm trying to connect the x and y coordinates of the moving point, then in order that I have a relationship which is universal for the entire trajectory, which is true for all points on the trajectory, that means that relationship should not depend on theta. That relationship between the x and y coordinates of the moving point should not depend on theta, it should be independent of theta. And when it becomes independent of theta, when a relationship becomes independent of the parameter, theta in this case or some other parameter in some other case, when it becomes independent of theta, then I will have enough courage to go ahead and generalize that relationship. Then I would replace h by x and k by y, the generalized coordinates of all points on the trajectory. Yes or no? So important. Yes. So the x and y coordinates will depend on theta. But I'm trying to find a relationship which will not depend on theta. A relationship between the x and y coordinates which should not depend on theta. Right? Obviously the x coordinate will depend on theta. The y coordinate will also depend on theta. But the question is there a relationship connecting the x and y coordinates of the moving point which is true for all thetas? And if it is true for all thetas, it will be true for all p's on the trajectory? Yes or no? That's my intention. So then, as simple as this, my objective is to eliminate the parameter. In this case, theta. That's my objective. If I've eliminated the parameter, that means I'm hitting the bullseye. I'm right away talking of an algebraic relationship connecting the x and y of the coordinates of the moving point, true for all positions of p. All positions of, if it's independent of theta, that means it will be true for all p's. If I have a relationship between the x and y coordinates of the moving point deprived of theta, then that relationship would be true for all thetas. That means for all p's described by the moving point. Yes or no? And then, as simple as this, see, I can say cos theta from here is h by b, and sine theta is k by a. And then I perform the last rights on this. I square and add. Theta gets eliminated. When I square and add, obviously h will vary with theta, k will vary with theta. But what will not vary with theta is the following. Square and add. 1, when I square and add 1 on the left hand side, and on the right hand side, h square by b squared plus k square by a square is 1. Yes or no? Squaring and adding. Which means whether theta is 28 degrees or 33 degrees or 57 degrees, agreed, the x and y coordinates themselves will depend on theta. But this number will not depend on theta. It will be true for all thetas. That means it will be true for all points on the trajectory described by p. Yes or no? And if this relationship is true for all points on the trajectory described by p, it should be referred to as the generalized equation. I can generalize this. I can replace h by x and k by y. I go ahead and generalize this. That means I say 1 equal to replacing h by x and k by y. This is the equation of the trajectory described by p. That means while this ladder keeps sliding, the point P moves to various positions. Its x and y coordinates will change. But what will not change is this relationship. At any given instant of time, if x was the x coordinate of the moving point, y was the y coordinate of the moving point, this condition will remain preserved, intact. And if this condition is true for all p's on the trajectory, this is referred to as the equation of the trajectory. Yes or no? This is the equation of the locus. Equation of the trajectory is referred to as the equation of the locus. And down the line, we'll get little loose about it. We'll say equation of the locus same as locus. Yes or no? Clear? I mean, let's say for example, you know, a simpler case. Very simple, just to take you through, you know, elementary stuff with simple illustrations. In the xy plane, let's say there is this origin 0, 0. Okay, a point P moves such that OP remains 5 units. Now, while the point P moves, the orientation of OP is changing with time, isn't it? That means this theta is changing with time. All right. Now, at any given instant of time, this theta would be different for different positions of P. Theta is my parameter here, right? So, at a given instant of time when the parameter is theta, let's say P has coordinates h comma k. Then do you realize h would be 5 cos theta and k would be 5 sin theta? So, now what is it that I'm trying to do? I'm trying to connect the x and y coordinates of the moving point such that there is no theta involved anywhere, such that there is no theta involved anywhere. That's what I'm trying to do. That means I want to have a generalized relationship connecting the x and y coordinates of the moving point, which should be theta independent. That means true for all theta. If it's theta independent, means that's going to be true for all theta. So then I square and add this, and I get h square plus k square equal to 25. When I square and add, this is what I get. Now, since this is true not just for this P, different P's for different thetas, we'll all subscribe to this condition, and therefore this condition is eligible for a generalization. This condition is eligible for a generalization. What do? I replace h by x and k by y. So then x square plus y square equal to 25 is the equation of the locus of the point P moving such. Yes or no? Right? So see, there would be various points on this trajectory. For different P's, you'll have different values of theta. But this condition would be true for all P's on this trajectory. That means this condition would be theta independent, parameter independent algebraic relationship. When I'm trying to find the locus, what am I trying to do? I'm trying to find a parametric independent algebraic relationship connecting the x and y coordinates of the moving point, moving subject to a condition or a set of conditions. Clear? Now let me go further, give you more illustrations. Can I wipe this off? Suppose AB is a variable line. Of length L. AB is a variable line of length L, say. Let's say equation of the variable AB is x by A plus y by B equal to 1. A and B are parameters now. A and B are my parameters. So while this line varies, the x coordinate of A, which is A0, and the y coordinate of B, which is B, that's going to change with time. Right? Yes or no? But let's say the length of the ladder or the line segment AB will remain the same. Right? Now, while A and B keep sliding along the x and the y axis, You have A changing, B changing. So my parameters now are inbuilt into the problem. A and B are my parameters. Now, I H a point P on this trajectory. I H a point P on this trajectory, which divides AB in the ratio 1:3, say, or 2:3. Say 2:3. P divides AB in the ratio 3:2. Okay. Now, while this so I can, for different values of A and B, I can have different positions of this line, different orientations of this line, and for different values of A and B, different orientations means different positions of P. P will then have different coordinates, X and Y, right? There is a path associated with P, there is a locus associated with P. I want to find the equation of the locus of P. I want to be able to find the equation of the locus of P, right? Now, let's say at a given instant, say P has coordinates H comma K. At a given instant, let's say P has coordinates H comma K. Clear? Now, H and K will depend on values of A and B. Choice of A and B will determine coordinates H and K. So H and K will depend on the parameters, but I am seeking to find an algebraic relationship that will connect H and K, which is deprived of the parameters A and B, so that I could generalize that, so that I could replace H by X and K by Y. Yes or no? You know what? Now, first things first. Section formula means H would be 2A plus 3 into 0 by 5, right? So 2A by 5. Yes or no? From section formula, K would be 2 into 0 plus 3 into B by 5. So 3B by 5. And I'm certainly not enjoying presence of A and B. I want to eliminate A and B. Switch off your mobile. Now, this would mean A is 5H by 2. A is 5H by 2 and B is 5K by 3. Yes or no? Now the point is, about time we killed A and B. Right? The fact of the story then is, this is A, this is B. Both A and B are changing with time. For different orientations of AB, small a and small b will have different values, will assume different values. That's why they're parameters. But what's not going to change is the following. A will change, B will change, but A square plus B square will remain L square. Right? This distance is remaining L. So A will change, B will change, but A square plus B square will preserve at L square. So this then would be the cardinal condition. What I now do is, this will be my eliminant. Because A can be replaced by 5H by 2, B can be replaced by 5K by 3. Let's do that. Replacing A by 5H by 2, B by 5K by 3 equal to L square. Hey, this then is a relationship connecting the X coordinate H and the Y coordinate K of the moving point, independent of the parameters A and B. That means for all points on the trajectory pursued by P, this relationship connecting the X coordinate H and Y coordinate K will hold good. Yes or no? And therefore, if it's a generalized relationship, bled of the parameters A and B, I can actually replace H by X and K by Y. That will give me the equation of the trajectory of P. So replacing H by X and K by Y, I have 25 by 4 X squared plus 25 by 9 Y squared equal to L squared, obtained out of generalizing, replacing H by X and K by Y. That means for all points on the trajectory pursued by P, if at any given instant of time P has coordinates X comma Y, then it will always subscribe to this algebraic relationship. This is the algebraic relationship, true for all points on the trajectory of P. This then should be referred to as the locus of P or the equation of locus of P. Yes or no? Sounds all right? Sounds good? Right? Let me illustrate a little more. Clear? Now, suppose I give you a point, fixed point 4, 2. Say there is a fixed point A, 4, 2. How many lines can I draw passing through the fixed point? Infinite. There is a family of concurrent lines passing through 4, 2. Yes or no? Obviously, 4, 2 would be a point, say, in the first quadrant, 4, 2. So while I keep registering more and more lines passing through this fixed point A, what would change? The intercepts P and Q would change. The intercepts P and Q would change. Yes or no? Right? The intercepts P and Q would change with while I keep delivering more and more lines passing through this fixed point A. Right? Now, at every given instant of time, there is going to be a variable triangle OPQ. There is going to be a variable triangle OPQ, right? So there is a variable triangle OPQ generated. There is a variable triangle OPQ generated. You can draw another line passing through A like this, and P will be here, Q will be here. And another line, and you'll have another position of P and a corresponding position of Q. Yes or no? So P and Q are my moving points. So now, damn thing. Sorry. Now, at every instant of time, there is a circumcenter of this triangle. Yes or no? Right? I have different OPQs, and each OPQ will have a circumcenter. Right? So there is a variable circumcenter, because if the triangle itself is variable, the circumcenter of this variable triangle would be a variable point. Yes or no? Variable circumcenter. There is a variable circumcenter associated with this triangle, right? I now want to find the locus of the circumcenter. So if it's a variable circumcenter, that means the circumcenter would be a moving point. The circumcenter would be a moving point. There is then a path associated with the circumcenter. There is a locus associated with the circumcenter, a trajectory. I want to find the equation of the trajectory, which would be the locus of the circumcenter. So I want to find the locus of the circumcenter. Now, no matter where P and Q lie, what is guaranteed is the following. No matter where P and Q lie, while I select more and more lines passing through a fixed point A, what is guaranteed is that every given instant of time, this triangle OPQ will be a right angle triangle because this angle will not change. This will always be a right angle triangle. Yes or no? I have, say, another line passing through. This will be my P, this will be my Q, but this angle will be preserved at 90 degrees. OPQ at all times will be a right angle triangle. And if OPQ is a right angle triangle, the circumcenter of a right angle triangle is the midpoint of the hypotenuse. The circumcenter of a right angle triangle is always the midpoint of the hypotenuse. Do you all understand that? No. How many of you want an explanation about why the midpoint of the hypotenuse would be the circumcenter of a right angle triangle? I can explain. Trust me, I can. Okay, so I'm assuming your silence means you've acknowledged that you know about it, right? So this is one instance of the moving triangle or the variable triangle OPQ, right? There are infinite instances of the triangle OPQ. Every instance of this triangle OPQ has a midpoint of the circumcenter C, has a midpoint of the hypotenuse C, which is the circumcenter of triangle OPQ, isn't it? Circumcenter C is always the midpoint of the hypotenuse. Hypotenuse, variable PQ varies, so obviously while P and Q are moving to different positions, we always have C assume different locations. So there is a trajectory associated with C. Am I confusing you? Then let me try harder. Okay, so then the x coordinate h and the y coordinate k of the circumcenter would be different at different instance of time for different positions of PQ. Only thing is, condition is that I'm not going to select this line PQ in a wild manner. I have to make sure that all such PQs that I have selected necessarily pass through this fixed point A. That's a basic premise. While that happens, what is the locus of C? What is the equation of the trajectory of C? So then, at a given instant, say this is the position PQ that I have selected, and at that position, h comma k are the coordinates of the circumcenter. And C then is the midpoint of PQ. And then can I say that P must have coordinates 2h 0 and Q must have coordinates 0 comma 2k. That will cause C to be the midpoint of PQ. That will cause C to be the midpoint of PQ. Yes or no? Right? Now, that means 2h comma 0, this is the x-intercept of the variable PQ. 0 comma 2k, that's the y-intercept of PQ. So I can write the equation of the variable PQ. Actually, what am I trying to do? I'm trying to connect the x coordinate h and the y coordinate k of the circumcenter in a manner that that's going to be true for all positions of PQ. It should not have any involvement of a parameter. And then once I have such a relationship, I generalize that. I replace h by x and k by y. Are you all okay with this or not? Okay, so let me write the equation of the variable PQ. X by 2h plus y by 2k equal to 1. That's the equation of the variable PQ. Yes or no? Different PQ selected passing through A will have different position points 2h and 2k. Will have different values of 2h and 2k. Now we go ahead and hit the bullseye. The last rites to be performed here. This line, no matter what h be, what k be, this will always pass through 4 comma 2k, 4 comma 2. This variable PQ will always pass through 4 comma 2, yes or no? That means irrespective of h and k, no matter where C lies, 4 comma 2 will always satisfy this equation because PQ by our very description passes through A. That means x equal to 4, y equal to 2 will satisfy this equation always, right? So putting x equal to 4, y equal to 2, that will give me 2 by h plus 1 by k equal to 1. Hey, that's a relationship that has connected the x coordinate h and the y coordinate k of this circumcenter, the moving point. Does it involve any parameter? It's true for all positions of PQ. It's true for all the C's described by PQs, various PQs. And therefore I can generalize that. What can I do? I can replace h by x and k by y. So 2 by x plus 1 by y equal to 1 will be the condition, will be an algebraic relationship, true for x and y coordinates for all C's described in the process. For all C's, for various PQs passing through A, you will have different C's, and those C's will have coordinates x comma y. Different C's will have different x, y's. But this algebraic relationship would be true for all the C's. And this then should be referred to as the equation of the locus. Yes or no? Are you all okay? Not okay? Now, can I wipe this off? So far so good, right? You're getting the idea of locus? Oh, you look very sedate. Be buoyant, ebullient, as long as you're not playing pranks with me. You know, your high energy levels will only boost my energy levels and I'll deliver better to you. So, you know, on the lower side, keep a naughty look on your face. If you actually get into some actions consistent with your naughtiness, I'll handle that. I know how to handle that. But at least, you know, carry some mischievous looks on your face. You can throw your arms and hands around, not an issue. I will have no qualms when you do that, as long as you're not chucking chalks at me. Right. Now, let me give you another situation related to locus. Different lines are drawn passing through the intersection of two fixed lines call them x by a plus y by b minus 1 equal to 0 and x by b plus y by a minus 1 equal to 0. Obviously, these two are fixed lines, they would intersect at a fixed point. Right? Yes or no? These are different lines, so b is not equal to a. B is not equal to a, but a and b are fixed numbers because they are fixed lines. And how many lines can you draw through their intersection? Infinite lines. There is a family of lines passing through the intersection of these two lines. Now, a line drawn such intersects the x-axis at A and y-axis at B. Right? Various lines passing through the intersection. Every time you draw a line passing through the intersection of these two lines, that line intersects the x-axis at A and y-axis at B. So A and B are moving points also, because different lines could be drawn passing through the intersection, leading to different intercepts A and B, capital A and capital B, right? And therefore, if A and B are moving points, then the midpoint of AB will also be a moving point. The midpoint of AB will also be a moving point, right? Find the locus of the midpoint of AB. Work on this. This problem that was posed to you. There are two fixed lines, x by a plus y by b minus 1 equal to 0 and x by b plus y by a minus 1 equal to 0, and very many lines are drawn through their intersection, and each of these lines would intersect the x and the y axis at variable points a and b. I want to find the locus of the midpoint of all the ABs. Now, what we do is, any line passing through their intersection in general can be written as a linear combination of the two lines. Yes or no? There was one line, one fixed line L1, which is x by a plus y by b minus 1 equal to 0 was one line, right? And there was another fixed line L2, which is x by b plus y by a minus 1 equal to 0 was another line. Now, any line that passes through their intersection can be written as L1 plus lambda L2 equal to 0, right? So, any line L, variable line L, can be written as L1 plus lambda L2 equal to 0. Any line passing through the intersection of L1 and L2 can be written as L1 plus lambda L2 equal to 0. Yes or no? For different values of lambda, you will get different lines L, but all these, no matter what choice of lambda you have, this formation of a line will always be a line passing through the intersection of L1 equal to 0 and L2 equal to 0. So what does this represent? A family of concurrent lines for different values of lambda. Lambda is my parameter here. Lambda is my parameter here. For different lambdas, I get different such lines passing through the intersection. So I've been able to successfully represent the generalized set of lines passing through the intersection of these two fixed lines involving a parameter lambda. Yes or no? Right? So then the variable line L is x by a plus y by b minus 1 plus lambda into x by b plus y by a minus 1 equal to 0. Yes or no? Now, just to write this line in a customary, in a traditional format, I could have written this line L as collecting terms containing x and y, 1 by a plus lambda by b into x, right? 1 by a plus lambda by b into x, the x term, the y term, 1 by b plus lambda by a into y equals, transposing the constant terms on the right hand side, equal to lambda plus 1. How about it? Right? Clear? Now to a and b are the x and y intercepts of this line. So let me write this line in the form x by something plus y by something equal to 1, so that I have the x and the y intercepts readily available to me. Yes or no? Right? So I write this line in the form x by, dividing by lambda plus 1, x divided by lambda plus 1 divided by 1 by a plus lambda by b plus y divided by lambda plus 1 divided by 1 by b plus lambda by a equal to 1. Yes or no? That's the equation of this variable line. Different values of lambda will produce different ABs. Clear? Different values of lambda will produce different ABs. How many of you don't understand this? Okay, now, but no matter what my choice of lambda is, these variable lines will always pass through the intersection of L1 equal to 0 and L2 equal to 0. Now, which means this variable line has variable x and y intercepts. Its x-intercept is a, which has coordinates lambda plus 1 divided by 1 by a plus lambda by b, comma 0, isn't it? That's the x-intercept of this line. This is the y-intercept of the line. So the point B has coordinates 0, comma lambda plus 1 divided by 1 by b plus lambda by a. Different values of lambda will give me different lines L, different ABs, different positions A and B. Yes or no? And for each value of lambda, there is going to be a midpoint M of AB. So while I choose different values of lambda, the position of A and B will change. So M will pursue a trajectory. There is going to be a path associated with M. Yes or no? I select lambda equal to 1, lambda equal to 1.5, 1.7, etc. I get different ABs, right? And therefore I get different coordinates of M. M therefore successively on choice of choosing different lambdas will pursue a trajectory. There is a locus associated with M. I want to find the equation of the trajectory. That means I want to find a relationship that will connect the x coordinate h and the y coordinate k of the midpoint M of AB, which does not involve lambda, the parameter lambda. I need to connect h and k independent of lambda. Once I do that, I then go ahead and generalize, replace h by x and k by y. Clear? Now, what is h? H would be half of this, k would be half of this, because M is the midpoint of AB. Yes or no? So h is half of lambda plus 1 divided by 1 by a plus lambda by b. K is half of lambda plus 1 divided by 1 by b plus lambda by a. What am I trying to do here? Eliminate lambda. If I and connect h and k. Now, one brute force approach could have been, from this equation I solve for lambda, cross multiply, solve for lambda and plug into this equation. I can find lambda in terms of HAB from this equation and plug that value of lambda in this equation and I get lambda. That's so dirty. So then, you know, this variable line AB dependent on the parameter lambda will have h and k as the midpoint, variable midpoints of variable ABs. I need to connect h and k by eliminating lambda. One thing, like I mentioned to you, I can solve for lambda from any one of these equations and plug into the other one and I can get an algebraic mess, right? Or I can get a little more effective. You look at this expression of h and k with a little bit of love and affection, and you'll be able to discover simpler ways of eliminating lambda, right? Now, so I need to connect h and k and eliminate lambda and then go ahead and generalize matters there. See, it would have been so nice if lambda plus 1 was sitting in the denominator, lambda plus 1 was sitting in the denominator, then adding them might have done some good to the whole thing, because adding them would have been simpler. So what? Let me then try with 1 by h and 1 by k, or just for simplicity, let me write this 2h, let me write this 2k. And let me do a reciprocal of 2h and 2k. And see if without brute force I can eliminate lambda. This would be 1 by a plus lambda by b divided by lambda plus 1 plus 1 by b plus lambda by a divided by lambda plus 1. Yes or no? Right? Let me add these two. The denominator, of course, is simple, so it will not call for humongous effort to add these two. 1 by a plus 1 by b get added. Then lambda into 1 by b plus 1 by a. Take 1 by a plus 1 by b common. You'll be left with lambda plus 1. Lambda plus 1 automatically gets eliminated. Do you see that? So this is like lambda plus 1 into 1 by b plus 1 by a divided by lambda plus 1. There goes lambda for a 6. Yes or no? Right? So we have a relationship which does not contain lambda. 1 by 2h plus 1 by 2k equals 1 by a plus 1 by b, which is this right hand side. Yes or no? I have an algebraic relationship that connects the x coordinate h and the y coordinate k of the midpoint m, whose locus we are trying to find. Yes or no? Generalize. Replace h by x and k by y. So when I generalize this, I get 1 by 2x plus 1 by 2y. Replacing h by x and k by y is 1 by a plus 1 by b. Yes or no? That's the locus of M. That's the locus of M. M pursues a certain trajectory and it will have different xy coordinates at different points of the trajectory, but all the xy's thus produced for various m's will subscribe to this condition. This then is the equation of the locus of M. How about it? Right? Now, can I wipe this? Yeah, you solve for the point of intersection in terms of A and B. Y equal to X? H equal to K? No, what? Okay, that's fine. That's fine. But you went through the trouble of solving for x and y in the process, right? Okay, shall I move? Now, let me give you another one. Say x by a plus y by b equal to 1 is a fixed straight line. With intercepts P and Q. X intercept P, say y intercept Q. Now, perpendiculars to this line are drawn. Obviously, perpendiculars to a given line, you can draw very many perpendiculars. So this is a variable line, right? Perpendiculars are drawn intersecting the x-axis at R. So this is my x-intercept, this is my y-intercept, just to make sure you understand what I'm saying. X-intercept of this line and y-intercept of this line is Q. Okay. And then perpendiculars are drawn to this line intersecting the x-axis at R and y-axis at S. Right? So obviously these R and S are variable points because different perpendiculars will give me different intercepts R and S. Right? Find the locus of the intersection of QR and PS. Find the locus of intersection of QR and PS. Okay, this problem. So there is a fixed line. This is P and this is Q. Alright. X by A plus Y by P and Q are fixed points, obviously. They belong to a fixed line. This is the line. And therefore, what are the coordinates of P? A0. Coordinates of Q? 0B. Alright. How many perpendiculars can you draw to this line? Infinite. Right? Say this is one such perpendicular. This is one such perpendicular. Alright. This is one such perpendicular. And this point is R and this point is S. R and S are moving points. R and S are moving points. Because if I draw different perpendiculars, will I not get different points R and S? The intersection with the X and the Y axis? No. Sure, na? Now, every time I draw a perpendicular, I can draw a QR and I can draw a PS. I can draw a QR and I can draw a PS. Now QR and PS intersect at a point, say A, at a point A. Now if I draw another perpendicular, I'll have different R and different S and therefore a different A. Different perpendiculars will give me different R, different S, therefore different QRs, different PS, and therefore different A's is what I'm going to get. Right? There is a path associated with A. There is a trajectory associated with A. I want to find the locus of A. I want to find the locus of A. Yes or no? Now, again, there are times that you have to just keep yourself mentally available with a situation on hand. Look at this triangle QSP at any given instant. Look at this triangle QSP. It's a variable triangle, isn't it? Because S is a moving point. Look at this triangle. Now, would you not want to believe in this triangle QSP? I want to find the locus of A, HK. Okay. Would you not want to believe? Okay. ST is one altitude, isn't it? In triangle QSP, ST is one altitude, isn't it? OP is another altitude because this angle is 90 degrees. Yes or no? OP is another altitude. And in a triangle, the three altitudes are concurrent, right? So this altitude and this altitude, they intersect at R. So if you join Q and R, that must give you the third altitude. Yes or no? Should QA not be the third altitude then? Altitudes of a triangle are concurrent. See, this is one altitude very clearly. This is another altitude from S. And therefore, if you join the point of intersection of Q to R and produce, then QA must be the third altitude. Yes or no? QA must be the third altitude because altitudes are concurrent lines. Do you understand that? Very clearly then. Slope of, that means AQ is perpendicular to PA. AQ is perpendicular to PA, yes or no? If this is the third altitude, then AQ must be perpendicular to PS and therefore PA. Right? So this would mean AQ, third altitude. And if AQ is the third altitude, slope of QA into slope of PS is -1. Right? I need to find the locus of A. That means I am seeking to connect H and K. So then K minus 0 by H minus A is the slope of PS, isn't it? K minus 0 by H minus A is the slope of PS. K minus 0 by H minus A into slope of QA. Slope of QA is K minus B by H minus 0. K minus B by H minus 0. And the product of these slopes is minus 1. Hey, generalize. Replace h by x and k by y. Yes or no? So generalize this. So y minus b into y divided by x into x minus a equal to minus 1. Cross multiply and simplify. That's the locus of a on generalizing this. So there are times, even though, I could have written this line in terms of a parameter, but this was an occasion where I did not allow the intervention of the parameter in the first place. I could have jolly well written this line as, if this line is x by a plus y by b equal to 1, I could have written this as x by b minus y by a equal to lambda say. This would always be a line perpendicular to this. Do you see that? Different values of lambda will give me different perpendiculars. And then I could have found r in terms of lambda. I could have found s in terms of lambda. And then equation of qr in terms of lambda. Equation of ps in terms of lambda. Creating so many possibilities of errors. And then solving and then eliminating lambda. Tough one, isn't it? It's best not to do all this. If you could identify that the altitudes, these are altitudes, then product of the slopes equal to minus 1 does the trick for you. Yes or no? Right? So, yes, there is a parameter which is invisible right now, and I didn't allow it to surface. It got killed even before it appeared. Right? Isn't it? All's good?